Your steel shift cables aren't actually stretching. Under shifting loads, they behave like solid rods, and the slack you feel is actually your housing failing. Let's kill the cable stretch myth immediately using material science. A standard stainless steel shift cable has a Young's modulus of roughly 190 GPa. Under the mere 40 to 50 newtons of force applied during a shift, the physical elongation of the steel is negligible, less than 0.1 millimeters over the full length. So where does the slack come from? It's predominantly housing compression and settling. A standard 2-meter housing run has multiple ferrules and bends. As these metal caps seat firmly against the frame stops and the plastic liner compresses, the effective path length shortens, mimicking a stretched cable. Friction is the secondary enemy of indexing, governed by the Capstan equation. Every bend in your routing creates a normal force against the liner. With a coefficient of friction around 0.1 for PTFE liners, sharp internal routing bends drastically increase the force required to release the derailleur, leading to lazy downshifts. This is why specific shift housing uses longitudinal strands, not a coil. Coiled brake housing can compress up to 2% under load, which destroys index accuracy. Compressionless shift housing limits this to near zero, transferring your lever input directly to the derailleur parallelogram without hysteresis. The barrel adjuster is designed to compensate for that initial housing settling, usually within the first 200 kilometers. However, once friction rises due to contamination, adding tension won't fix the physics. If your shifting is vague despite adjustment, follow this decision logic. Stop blaming the cable. Replace your housing for perfect indexing.